Hello everyone, I'm Kaji Sanul Mubin. First of all, thank you for giving me the opportunity to present our recent research with you. Uh, First, let me introduce you to myself. I'm Kaji Sanul Mubin from BRAC University, Dhaka, Bangladesh. Uh, I have done my graduation in 2022. My research interests are in differential privacy, federated learning, and medical computer vision. Today, I'll talk about the decentralized federated learning and deep learning leveraging XAI-based approach to classify colorectal cancer. So let's start with why cancer. As we all know, cancer is the most deadliest disease in the world. Especially, colorectal cancer is ranked from second to fourth deadliest according to the cancer mortality. And recent research done by American Cancer Society found that from 136,000 people that are diagnosed with colorectal cancer, 50,000 of them died. Uh, there's been a lack of research, especially in the field of colorectal cancer and medical computer vision. Uh, in this paper, we propose a federated learning-based approach to classify colorectal cancer that can achieve an accuracy of up to 96% based on our own developed models. So, some background research has been done in cancer. For classification, we have one paper, automated detection of polyps, that and the polyp detection via embellished learning and discriminative feature learning. These papers are concerned with learning or finding patterns by using the polyps. We have also one paper named Deep Convolutional Neural Network-based lymph node metastasis prediction. This paper focuses on lymph node that is developed during a very early stage of cancer. And for privacy-centric research, multi-institutional deep learning modeling without sharing patient data is one of the recent research. And for federated learning, we have also one existing research on federated learning in breast cancer density classification. Uh, from this background research, we found out that noise is one of the major issue when it's come to training neural networks and CNN in general. And also, many research has used different dataset for colon cancer and rectal cancer. This results in that a model cannot be trained for both classifying colon cancer and rectal cancer. So we have used a single model to classify both colon and rectal cancer in this regard. And also there's a scarcity of publicly available data, which really hampers the advancement and the research on medical computer vision in general. In federated learning, we have problems such as fairness and participation of local clients and the heterogeneousness of the machine learning or deep learning models. And finally, the fundamental problem of machine learning, that is overfitting and underfitting issue, is one of the problem that we have to also consider during our research. So our objective is to create a framework of federated learning based approach to not only classify colorectal cancer but also classify very other forms of cancers in future. We have also implemented the explainable AI for visualizing the features that has been found in our research. This can benefit the researcher and also the medical analyst who are conducting research on cancer in general. So our workflow starts with we trained 5 different CNN models from various generation, and comparing then compared their metrics, how they perform. Then based on that matrix, we chose the best model as the global and local algorithm for our federated learning approach. And finally, we have used explainable AI to visualize our results. So let's talk about the dataset we are going to be using. So our dataset consists of 100,000 non-overlapping histopathological MRI images of colon and rectal cancers. Uh, this was collected thanks to NCT Biobank and UMM Pathology Archive in Germany. Our images are in 9 different classes. 7 of them are not cancer affected. However, 2 of them are cancer affected. These are the cancer-associated trauma and the colorectal epithelium. The image dataset is reshaped with 224 into 224 pixels and with a rate of 0.5 micron per pixel. So let's talk about the pre-processing we have done. We have researched our images for both federated and CNN model learning. This was done to reduce the computational power that we were going to be requiring. For CNN model, we have split our dataset in train, test, and validation. And for federated learning, we did not use validation. We used train and for evaluating test. So let's talk about the selection of CNN models for our research. We have selected 5 different models from various generations of convolutional neural network. We have chose the VG16 and 19, then the inception, and finally the residual model using skip connections that are the ResNet and ResNext 50. Here we can see a basic structure of our CNN models. Note that each of our models have quite different structure. So we can see we have feature extractors, which are the regular architecture of our CNN, and then after that we have the fully connected layers. And finally, we have implemented an explainable AI to label which part of our images are classifying right in the right way and which are not classifying the right way. Here we can see that the green marked area are the superpixel that increase the probability of a class being of a image being of a certain class, and vice versa, the red marked area decreases the probability of a class being in a certain class. So let's talk about the main focus of our research, which is federated learning. Uh, we have used the federated averaging framework for our research. However, there's a lot of variant of federated learning nowadays, QFed and federated aggregation. Our dataset was divided into 10 different clients, each representing a institution or a hospital that trains their own data, then create a model or update a model, then return that model to us, and based on that weight, we average them and we develop a generalized model, and then we send it back to our clients. So this is a cycle that happens all the time in federated learning, in each epoch actually. So this is a detailed workflow of how we have done it, starting from the distribution of our dataset, then training, and then returning our models, and updating our global clients. Now let's talk about how much of a result we got. So here we can see that our VGG 16 and 19 is not the best when specifically on our dataset. We can see that ResNext 50 perform better in all metrics, all accuracy and loss metrics. So this is why we choose ResNext 50 as the global model for our federated learning. Here we can see a more focused view of ResNext 50. We have done up to 39 or 40 epochs, and we can see that the overfitting issue is not visible. And we have also generated a confusion matrix to verify whether our model is working perfectly for all the different classes. Now the result of our federated learning. The cycle that we talked about updating local clients, then averaging and returning the values to local clients happen for almost 20 epochs, and by this time we managed to achieve accuracy of 96%. We can also see the loss decreasing as we theorized in our research. So we can say that our federated learning managed to achieve a very good accuracy. But also we can also focus on the individual clients that we have used. Here we can see that these are the 10 clients that we had, and the patterns of upshifting pattern of their accuracy mean that they are improving individually themselves. That means without using the global model, we can individually use the local model as our training. However, it is not the most efficient way. And finally, we can see the local loss comparison for all of our clients and the categorical accuracy comparison here. And to evaluate our finding that it is working for each of our classes, we have generated a table that provide precision recall F1 score for all of our classes. And also, we get a general accuracy of 96%. Finally, let's talk about the future plan and the to new doorways that opens in our research. For example, the hyperparameter tuning can be done more efficiently. There can be a lot of variation in neural network, and we can use more updated convolution neural network for our research. And also, our models were our data set that we had was almost equal in the class distribution for all of our classes. However, it is not true in real world. In real world, we might get a data set that has a lot of images in one class and not a lot of images in other. So this creates a problem that has to be addressed when practically implementing in the real world. And finally, the participation of each of our client and how important their performance is to the whole averaging process is called fairness in federated learning. So this is also one of the factors that we have to consider when we are using this model in real world. Uh, for better results in fairness, QFED and federated aggregation has been developed. So this is also a framework that we that can be used in future. And finally, our goal is to develop an industry standard system of federated learning so that it can be used not only in cancer research but also many other research in the medical computer vision field. Thank you so much for thank you so much to everyone and for your time. Uh,